My name is Emiliano Cornejo Esquivel, and I'm going to present Activity 2.2, uh, which is a simulation of a washing machine. First of all, here we have the setup for the external interrupt. First of all, we enable the global interrupts. We set the external interrupt to happen on a rising edge, which basically means we activate it by sending 5 volts to a certain pin. We set the flag for the interrupt being over, and we allow external interrupts and set the interrupt pin as an input. Inside of our interrupt function, we basically copy the settings of port C in order to clear it up, and afterwards update it and make it as it was before the interrupt. Inside this interrupt, we basically just send a message to the user that the device is on pause and that he has to open and close the door if he wishes to restart the cycle or to continue the cycle. Here we have the different cycles of the washing machine, the pre-wash, the wash, the rinse, and the spin. In each of them, there is a display for the uh, minutes that are left, and in the options of the interface, you can set the actual delay between each minute. This is done for each cycle. Here we have the in each cycle we define the variable used in the loops, the variable used for the cursor of the LCD display. We start the ports and the LCD, set this constant in order to define the time left as in 4 bits, and initiate the interrupt in every cycle except in the spin. In the case of the spin, we don't want the user to be able to interrupt the sequence, so we disable global global interrupts, and well, we disable global interrupts. And this is the main function for the interface for the user. In this part, we also disable the use of interrupts, and we start the ports and the LCD display. Basically, this is just a collection of states uh, which transition from each other based on the input of 3 buttons, right, center, and left. We have like 14 states, uh, which in total gives us 3 main menus and around 10 options. Well, 11 options. So here we have all of the states. In all of them, this little program was used, which basically just waits for any of the buttons to be pressed, and then based on the button pressed, sends the LCD display to a different state. This is the function that actually sends uh, this interface to the application of the cycles. We load them mm, with the remaining time of the third cycle, and the time constant that is being used. This time constant is a divider of the minute weight. And that's basically it for the interface. Here we have the time options. We can see how the time constant is set and how this constant is then used in the cycles in order to divide the minute weight. Each of the minutes you have to wait. Mm, this is all of the interface, each of the possible states. And this is the starting program. We basically just put my information for the user to see and set the initial time constant, stage for the cycles, and a state of the interface. All of it is done in this starting point. So we could, for example, open it up in a certain menu or as with a certain time constant or cycle of the washing machine as a default. Well, this was the programming. Now we're going to go to um, the simulation, which is right here. Here you can see how the buttons actually interact with the interface. It's completely free and without restrictions. So we're going to start by setting the times constant to dividing by 60. And since the default for the cycle is already pre-washed, we don't really have to change anything in that regard. So once you start the pre-wash, the water valve is opened and the door lock is also activated. You can interrupt this cycle and you have to open and close the door in order to continue. Here we can see the wash cycle in which the motor is alternating directions. You can also interrupt it and it turns the motors off. Then afterwards, it starts on its own, applying the door lock. So yeah, that one takes a while. So we're going to go to the next cycle. And this is the rinse cycle. You can see that the water valve opens, the water drain opens as well, and the door lock is activated. You can also interrupt this cycle with the external interrupt we talked about in the programming. All right. In the last seconds, the motor starts. And afterwards, in the spin, we open the water drain and the motor activates. In this stage, you can't really use the interrupt for the safety of the user. And that was the presentation of the simulation. Now we're going to go for a presentation of the physical circuit in this video. Here we can see the circuit, the LCD display. The motor actually didn't work with the H-bridge, el puente H, and I actually measured the voltage output of said bridge, but it was very small, and the motor needed a lot more voltage. I think the output was of about zero point 0.5 volts, and that was taking into account all of the transistors that needed to be uh, used for that bridge and the voltage drop between them. So in the end, I ended up replacing the motor for these two outputs. And well, you can see how the interrupt works in the physical display, how in the watch cycle the motor alternates direction, and in the spin cycle, it doesn't let you um, interrupt, and the motor is constantly spinning in the same direction. And well, in the beginning, we also saw, yeah, there's the interrupt, which doesn't work. And well, in the beginning, we also saw how the interface responded quickly to the user input. So that was my video for this activity. We presented the programming, how it works, the simulation in Proteus, and finally the circuit in a physical form. So that will be all, and thank you.